This is a patch a model. It could also be integrated with GIS in an interesting way. Okay, although for reasons of time we won't spend time doing that right now. So I'd like you to create a new model, and this will be called gridded hybrid model with a GRDDED. Gridded hybrid model, and I'm going to put it in my canonical location for this boot camp. Okay, there we go. And the time unit of this model will be, I think it's, I should know this. I believe it's years. Yeah, years. Okay.
So I just can't remember. You want to change the time scale.
So after the model's created.
Yeah.
So you go. Yeah, you go up to the model itself. Yeah, and as long as you do it right after it's created, it's no problem. If you wait for it after you've created some things, that can be cause of big problems. Okay, so ladies and gentlemen, this is going to start out in a familiar way. So firstly, I would like you to go create an agent class. But this agent class will be called something somewhat unfamiliar. It's called Patch. P-A-T-C-H. With, of course, a capital P to indicate it's a class. It's denoting a set of possible patches. Okay? Patch hood with respect to this model. So patch. Okay? And having done that, ladies and gentlemen, we are going to go to patch, and remember, as a general rule, it's more favorable if you can place the visual representation on things up front rather than after the population is created. It can be bad news if you do it after the population is created. So, ladies and gentlemen, I would like to go, and I'm going to ad-lib a little bit here just to improve this. I'd like to get a rectangle, and I would like to center it, if possible, on this origin. Okay. And specifically, this is going to be because it's the rectangle, and I'd like to set its width, ladies and gentlemen, and its height to both be 50 and 50 for space and height. You can futz with it visually, but it's easier to do this. Its X location will be minus 25, and its Y location will be minus 25. So it will be centered on this grid point, okay? And it's of width and height, ladies and gentlemen, 50. Are we okay with that? So note again the meaning of this grid point. If something is placed bang on the grid point, they will be located bang on their logical location. So the middle, when we see this little patch here, this rectangle, its middle will be the logical location of the thing we're dealing with. And if we were doing this in GIS environment, which will be very straightforward, the middle of it will be located in the GIS coordinate associated with that patch. And we could populate it with terrain information, for example. Okay? Okay. Next, ladies and gentlemen, I would like to go and create in main, with an eye towards running the model quickly to see if there's a problem. I would like to go to main, and I would like to create a parameter that is called count patch rows. Okay? Count patch rows. And another one called count patch columns. And guess what type each of these parameters is going to be? An int indeed. And ladies and gentlemen, by default, I'll make them 20 each. 20 rows, ladies and gentlemen, 20 columns. Are we okay? Okay. Okay, we're cooking with gas. Okay. Now I'd like you to create a population of patches. And it will be called, ladies and gentlemen, patches. And it'll be a population of agents, and the number of agents will be count patch rows times count patch columns. Okay. Now, I would like to go set, before we run this model, so I would like to go to main. We're going to go down main, specifically down to the space and network area, ladies and gentlemen. And we are going to set a discrete space. Okay? The columns of that discrete space will be count patch columns. The rows of that discrete space should be count patch rows. And we're going to set it to have 4 neighbors, so Euclidean neighborhood type. So we're going to have 4 neighbors, north, south, east, and west. Is that okay? Okay. And the layout type, ladies and gentlemen, will be arranged. Arranged. So let me rehearse those again. This is in the space and network, and I will in fact enlarge this so you can see it. Space and network of main, it'll be discrete space, columns, count patch columns, rows, count patch rows. Neighborhood type is Euclidean. The layout type is arranged. And the network type we won't be messing with. Are we okay with that?
You had it as columns was count patch?
Count patch columns and count patch rows. Those are the names of the parameters we created. So you should be able to auto-complete this. So if anyone wants to see that again, here we have it.
So can you discuss a bit more about continuous discrete space differences?
Sure. Thank you. So AnyLogic supports 3 basic types of spaces. They're labeled there: continuous, discrete, and GIS. Continuous and GIS are pretty darn similar. So,
well, we didn't even switch that to GIS when we did the GIS model.
I thought it was actually on GIS, but I think it may have been done automatically when we dragged in the map. In any case, continuous and GIS are pretty similar. Yeah. Okay. Now I just caused myself trouble. Okay, Kurt. Now I'm in trouble. Okay. Now I'm really in trouble. Okay.
Why are you in trouble?
Because I just switched it to GIS space to illustrate what would
Did it generate a map?
Yes.
Oh.
Okay, now we're cooking with deadly gas.
I just dragged in a map,
Yeah.
and it switched the space type to GIS and made it so I couldn't switch it up. I couldn't change
Yeah.
its type.
Yeah.
So it does switch it to.
Yeah. Okay. So GIS and continuous are very similar. Okay. Discrete space is basically dividing up space into grids. And each grid, this is very important, and it's a non-obvious constraint, each grid can contain either 1 or 0 of a given agent. I'm not actually sure about different agent types, if you can have one of several agents in there. But I think you can have 1 or 0 of a given agent, so it can either be occupied or not. And the idea is that there's mutual exclusion. Either it's occupied by a building or it's occupied by farmland. It's a little patch that's occupied. Occupied or unoccupied. By contrast, continuous space, you have not things divided into quantized blocks, of sort of fixed X and Y sort of row and column, but rather it's continuous space, and things can cross. There's really no notion of mutual exclusion. Things can cross each other's paths. The idea is, you're looking at it from such a distance that for all intents and purposes, you don't have to worry about this thing excludes this other thing. So if you want to have exclusion, you can enforce it yourself, but it won't enforce that. And the notion in a continuous space of rows and columns disappears. You just have X and Y as continuous coordinates. And that's what we've been dealing with mostly. Get X, get Y of something. In a GIS bus, similar. Get latitude, get longitude, to whatever level of detail. We didn't rely on patches being exclusionary there, and you located one and only one patch, and you hop to another patch, and nothing else can be in your patch. Whereas discrete is kind of more that model. Now we're going to use it in a special way here for a complete grid that could draw on GIS information, including GIS terrain information. Okay? So is that helpful? Okay, ladies and gentlemen. So let me go back to this and let's run it. Okay? Okay, it's an unhappy camper. Let's go see why it's unhappy. Cannot convert double to int. Okay, I probably forgot to declare certain things. Yeah, okay. Count patch columns should be integers. Did I thought we did that, but I thought I said that, certainly. Let's type int. Okay, this is double. That's why. Okay. I didn't do both of them. Okay, now it's a happy camper. Both of these should be integers, right? Be okay with that? Okay, so now run it. And what do we see now? A grid, right? Okay, now, again, we could draw in from GIS coordinate information, texture information, and populate each of these elements. We could associate them with terrain. We could associate them with, whether it's, for example, water or not. We could associate them with vegetation amounts, etc. We could associate it with prion levels for deposition of prion. And, well, if shown 20 by 20, we could have much larger ones. Now, in this case, ladies and gentlemen, we have to be cautious because we actually didn't see the full extent of this little patch because we didn't leave enough space. So I'm going to reduce it. We have two options, basically. We can reduce it from being 500. This is 50 width, 50 height, and we have 20 of them. So either we need a space 1,000 by 1,000, or we need to have fewer count patch rows, count patch columns. So I can make this 1,000, make it 1,000 by 1,000. That would be perfectly logical. And alternatively, I could reduce count patch rows or count patch columns, or make this smaller. I'm going to make it 1,000 by 1,000. So here we have our grid. We okay with that? Now, the key thing to realize is each element of this grid is an agent. So you notice there's 399 agents, 20 by 20. is 400, and it's 0 through 399. If you had just 0, it would be 1. If you had 0 and 1, it would be 2 agents. So 0 through 399 is 400 agents. Okay? Each of these is an agent. Okay, so ladies and gentlemen, each of those could read in, again, information, but we're going to put in place some mechanisms here for dynamics, and we're going to do so post-haste so that we can not get out of here late. Okay, so so now what I'd like to do is to introduce two more parameters into main, and one of them will be called patch mortality threshold. It'll be a double. And one will be called max visible population threshold, also a double. Okay. Okay. Now, I should know what these are, and I have what values. I'll get those values, I think, in a bit. I may have to refer to a reference model here. Okay. Yeah. Pardon me while I just refer to a model that I provided you. So here, okay, yeah, and here, gridded hybrid models, gridded system dynamics models. Yeah, okay, fine. Oops. Oh, okay. Okay. Well, I'll have to come back to this. It looks like I thought I would have that. Okay, gridded system dynamics model. So what's the matter with this guy? Okay, yeah, loaded it this time. I don't know what's up. Okay, so those guys should be of value. Here we are. So patch mortality threshold should be, oh gosh, okay. Okay, neither of them have default values, great. Okay, what are the values given here? Okay, 500 for patch mortality threshold and 20 for max visible population threshold. 20, okay? So, apologies. So this would be patch mortality threshold 500 and 20 for the max population threshold. Okay, good. And this should be okay. Okay, now having done that, I would like to go and create a variable. Okay, and this variable is going to be used to keep track of some information, and this information is going to be used again and again and again throughout the model's operation. So we want to compute it twice, and this variable is going to be called neighboring patches. Okay, so here's our model, and we want to add a variable called neighboring patches. Oh, sorry, excuse me. This variable is going to live, it's going to live in patch. Okay, so in patch, yes, it's going to be called neighboring patches. Neighboring patches. Okay, and its type, ladies and gentlemen, is going to be other. And the other type that it will be is this. This means an array of agents. In other words, it's like a vector of agents. Okay? Okay. Okay?
Those are square brackets?
Those are square brackets, yeah. I'll put them up on the big screen. Like that. So this is how you say it's an array of agent. Meaning it's kind of conceptually it's kind of a vector of agents, one after the other. Okay? Great. Okay. So we're in good shape for that. And now, ladies and gentlemen, I would like to go to a place here where we we're going to place into this patch as well several more parameters, or several parameters. One of them is going to be initial immature, and another will be initial mature. So these are initial population counts for immature and mature. Okay, initial mature. And both of those are going to be double precision values, and they're going to have a default value, if nothing else is specified for them, of uniform 0 to 10. Same thing for initial mature. Uniform 0 to 10. So initial immature is initial mature. Okay? Okay. 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 Next, I would like you to go and I would like to add stocks. From the System Dynamics palette, I would like to add stocks called mature and immature. Okay? And those stocks are going to be a key part of the model that's going to be emerging. Okay. Good. Okay. Great. Okay. So within patch, we're going to go to System Dynamics and add two stocks. One is going to be immature, and that should be to the left. And the second one should be mature, and that should be to the right. And they should be roughly aligned. Mature. Okay? I like to capitalize them. Now, the initial value of immature will be given by the parameter initial immature. And the initial value of mature will be given by the value initial mature. Okay? Okay. So, there's going to be several flows here. Okay? So, one flow here is going to be a flow from immature to maturation. Okay? Flow from immature to mature, like this. Now, I happen to align these, as it turns out, it so happened it was quite well. I'm going to pretend I didn't. I'm going to drag that away. So, okay, well, we can deal with this if we have to. So this will be called maturation, this process. And I am going to, if you get like this, I'm going to drag it so it lands on this stalk. Do you see what I'm doing? I'm dragging this so it lands on this stalk. And similarly, I'm going to drag this so it lands on that stalk. Immature and mature. Okay? That's maturation. There is next going to be a flow here called deaths. and there's going to be a flow. Oh, notice that this didn't land quite properly, so I'm going to correct it. In other words, it landed like this. If you something like Kurt can help you get that back on the stock, it's a common thing, and it can be a bit futzy. Okay, and now I'd like you to add in a net migration. So I'm going to drag in a flow here, and net migration is going to go vertically into the bottom of this. Okay, right there, and we're going to have to link that up like that. Net migration. Okay. Okay. So these ones refer to initial mature, initial immature. Now, because these refer to these, ladies and gentlemen, because these stocks refer to the values of those parameters, we need to actually connect the values of those parameters to these stocks. And what I'm going to suggest in the interest of space is that you put this underneath there, and we provide links from there up to the mature. Okay, so here we go. There we go. Okay, just like this. And similarly for these links, we want to do it from initial mature to mature. You notice those links are dotted, or at least they should be dotted. The fact that links are dotted indicates their initial value connections. Okay, now does anyone need help?
So how do they end up not dotted? I mean, yeah, it's still solid. No, it is dotted.
Well, yeah, if you move it seems solid, you select it. But you see how, here?
Yeah, it's when to click on something else.
Yeah, exactly. Okay, so ladies and gentlemen, I would like to go now and drag in, we're much of the way done building this, but I'd like to go drag in now a few additional parameters. One, I'd like to drag in a patch population, a thing called patch population. Here we go, patch population, and this population is going to be the sum of immature and mature. Okay, so it's going to be the sum of these two. So we're going to need to sum that up. Okay, and so that's one thing. And let's go set patch population to be the sum of those two. So it's going to be the sum of immature plus mature. Notice I dragged a dynamic variable in. Okay? Okay. Does anyone need help?
I've got a dynamic variable. I was like wondering why it wouldn't work, but it needs to be dynamic, obviously. Or to link.
Yeah, it needs to be linked. It's got to be dynamic for it to allow those connections to it rather than a parameter.
Well, it could be a variable, though, also, that would work. It's an orange variable from the agent base.
Well, but it wouldn't update it automatically.
Right.
Yeah.
But it would, the link would work.
For
Yeah.
some reason my lines are red. Won't let me go.
Yeah, maybe because it's not
Which lines are red?
linked up there.
Right.
Okay?
So
Next, ladies and gentlemen, I'd like to
population
drag in a mortality rate.
means you need to drag in one of those instead of
And
delete that one.
this mortality rate is going to influence deaths, as you might expect. Okay?
And then make that one pet population.
And deaths are going to further depend on the number of mature ones, these. Okay? Okay, so deaths here should be deaths equals, oops, what am I doing?
Probably delete
This should be mature times mortality rate.
Is it also a dynamic variable?
Sorry? Yeah, mortality rate's a dynamic variable, it turns out. Okay. And then here we're going to have patch population is going to influence mortality rate. Okay.
What's the value for the mortality rate?
We're going to fill in a formula for it.
Okay,
Yeah.
so I didn't miss that.
No, you haven't missed that yet. But there's a formula for deaths, which is mature times mortality rate.
Oh, I mean,
And then for maturation, it's immature. Okay, for this guy here, ladies and gentlemen, I would like to go add to main a parameter called mature age, or age of maturity, that would be better. Age of maturity. It's a double, and its default value will be 10. Oh, just double check that, but yeah, I thought that was correct. Age of maturity that I assumed. Initial immature, yeah. Okay. Okay, that's kind of odd. Okay, maturation age, yeah, 10. Okay. So, ladies and gentlemen, so now back to the patch. Maturation should be given by, it's a first order delay with immature, so connect immature up to it, and it's immature divided by age of maturation, main dot age of maturation, age of maturity, I guess call it. Okay, age of maturity. Okay. 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 Great. Okay, and so we have a formula, let's be clear, a formula for maturation, which is immature divided by age of maturity. We have a formula for mortality or deaths, which is mature times mortality rate. And right now, for the time being, I'm going to actually make mortality rate a constant, okay? Just as a trial, it's going to be a constant of 0.1. Okay. Okay. Now, the key thing here is going to be, or a key thing here is going to be this net migration rate. This is all endogenous, this top stuff. But the net migration is where it's going to come in from neighboring patches. The rest is going to be all within this patch. Okay? So we're going to want to, within this patch, simulate the flow in here. through net migration. Now, the formula for net migration is going to be get net immigration rate. Okay, so we're going to create a function here that's going to be called function called get net immigration rate. Okay, so let's drag that into here. Function get net immigration rate. And it's going to return a value, which is a double. And we're going to fill this function in just a moment. But net migration here should call that function. It should call get net immigration rate. Okay. 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 So we're going to have to do this. Yeah, Kurt, maybe you can help Tiffany get caught up here. So again, this is a first order delay with immature divided by age of maturity. That's in main, a parameter in main that should be 10. And this is a first order delay mature times mortality rate, where mortality rate is 0.1. Okay. And these guys are referring to the initial value. Okay. And now this is going to be get next immigration rate, and that's what we're going to define right now. Okay. 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 So, ladies and gentlemen, let's turn our attention to get net immigration rate. Now this one is going to be a little bit more involved, but it will be it won't be too bad. Okay, so we're going to say here, right? Good. We're going to say double. We're going to have sort of a running double. Running total immigration rate equals 0.0. Okay. Now, I'm going to put down here, first, handle the case where the neighbors are not yet set, because apparently this can be called before neighbors are set up. So if neighboring patches equals null, in other words, if we have no record of neighbors yet, then we're going to return 0.0. Okay. Otherwise, for each agent in the neighboring patches, we're going to do something. Okay? Okay. Okay. Good. So what we're going to do is we're going to say patch. So I'm sorry, I'm going to rephrase how I'm saying this. This is going to be for each neighbor agent in the neighboring patches. Neighbor agent in the neighboring patches. We're going to have a neighbor patch that is just going to be that same agent just treated as a patch. We just know that they're a patch. That's what this means, okay? Patch. Treat them as a patch. Okay. Now, okay, so if neighbor patch is not null, in other words, if we have a neighbor there, north, south, east, west, maybe on the edge, but if we have a neighbor there, then we're going to add in to our running total of the immigration rate something that's reflective of that neighbor's contribution. So we're going to add in to our running total a migration diffusion coefficient. Okay, now I think that's in Maine. I thought we added that. Oh, we haven't added that yet. We need to. Migration diffusion. Oh wait, no, it should be in this patch. I thought we added it, but no. Okay, diffusion coefficient. We will. Times, and this is what we should add. Times neighbor patch dot mature minus our mature minus mature minus this dot mature minus this dot mature mature. Okay, and then, and we should really put this in parentheses, and then return the running total immigration rate. And I'll explain what this does. Now, for this to build properly, for this to be understood, we're going to need to provide it with an additional coefficient, additional parameter. So let me put this up on the big screen. Okay, so we're going to start with 0. And if we don't have any neighboring patches that are filled in, which can happen before the model's set up, because this is occurring in a flow, it might not have set this up, we're going to return 0. It doesn't matter at that point. Okay, if we are in a situation where we have some patches at least, go loop through them. Go loop through these patches. And try to establish each of them as a patch. Okay, try to say, okay, I want you as a patch. Now, if that's null, in other words, if that patch, that neighbor doesn't exist, if it does exist, in other words, if it's not null, then add into our immigration rate some diffusion coefficient, some coefficient for how much their mature individuals are likely to come into our cell. And this is the imbalance between there. So if they have a lot more than we do of mature individuals, they'll tend to flow into our cell according to this diffusion coefficient, to our patch. They'll tend to flow in. So think of this as like sea lice. There's a bunch of sea lice over in the patch next to us, and they'll tend to flow into our patch over time.
By the same token, though, if we have more
than them, then we're going to end up having negative immigration. In other words, we'll flow out through there. Yeah.
Mature and then main age of maturity. So you need to create age of maturity.
Yeah.
Sounds like a movie.
Research.
Population.
You haven't set the value at equals, so it's going to be mature plus mature.
If neighboring patch equal null, return 0. Otherwise, otherwise do this. So for each
The value is?
neighbor, we have to see if that's null. If so, or if not, we add in its
What's
contribution.
the age of maturity?
It's 10. It's in Maine.
10, just 10?
Years.
10 years.
Yeah, I mean, that's the time unit of the model. Yeah. Yeah. Okay? So that's what's in there. Now, it's not going to be a happy camper until we define this diffusion coefficient. And I thought we had defined that before, but I guess I'm wrong. So this is this migration diffusion coefficient. We need to define that for the patch. So we need to drag in a parameter to the patch called migration diffusion coefficient. And that could reflect the fact that it's harder to migrate upstream or it's harder to migrate in this area than this other area. So it's migration diffusion coefficient. And initially it will be a coefficient of 0.01, let's say. I'm going to go check out what value previously used for that. Okay, here we go. And let me see, migration diffusion coefficient. Okay, its value that I used was what? Patches. Okay, come on. In this other model I used, 0.01. Yeah. Okay. So migration diffusion coefficient by default is 0.01. Okay? And then, okay, ladies and gentlemen, and then there's one other thing we still have to do, which is comparatively small but fairly important. And that is, we need to add in the neighboring patches. We have to initialize it. We have to sort of set it to be, yeah. So what we're going to do, ladies and gentlemen, is we're going to go and we are going to set something which we haven't done before. And this is not the only option, but you should probably see this at least once. Ladies and gentlemen, for the patch, there's going to be, if you go to patch, there's a thing called on startup. Do you see that? If you go to the patch and you go to on startup for the patch, it's down in agent actions for the patch. You should be able to go there and you should be able to say neighboring patches equals this dot get neighbors. Okay? And before that, neighboring patches, this variable, before that, let's make it null, so it refers to nothing. So what did I do? I did two things. I went to patch, I set the variable neighboring patches, its initial value to be null. We didn't fill it before. That means initially it doesn't point to anything. It doesn't refer to anything. That's step one. Step two, for the patch itself, I went down to agent actions and I said neighboring patches equals this dot get neighbors. In other words, we get the neighbors for this patch and remember them in neighboring patches. Is that okay? Okay, now, there's just one final thing, and it's going to be a crowning beauty.
Crowning jewel, perhaps?
Yeah, that's right. It's going to be a crowning jewel, ladies and gentlemen. And for this, we're going to have to appeal to your memory because it's going to involve something you've experienced before. It's going to involve LERP. Okay? I would like you... Yeah, indeed. Okay, this is really slow right now. I'm not sure why. Okay. Okay, bad things are happening on my computer. I'm not sure why. Okay. And ironically, while I'm saying this, It says Pigdog Slow. Indeed, okay, yeah, dysfunction is occurring.
So that should function.
Okay, I'm not sure quite what's happening here. So pardon me for a second. Here's AnyLogic Professional. Okay. Okay, something interesting is happening. Let's try that.
What's your
Okay.
this one here?
Okay, well, this is getting Pigdog Slow.
Yeah.
Okay.
Here's another thing I keep.
Okay, so
Myself.
closing AnyLogic, we already opened it and was able to do this. Okay, so now this builds
So
happily
then it's not gonna be a name, right?
for me. Okay,
No, that's right.
okay, and oh, we still need to set the lerp. That's what I was doing when
It's in the function.
things
Yeah.
got slow. Okay, so ladies and gentlemen, for the lerp, what we're going to need to do is to put in place, okay, yeah, right, okay, yeah, fine. I did this the old way.
Okay,
Okay,
that's what it was. Not bad.
good,
Yeah.
good. Okay, so ladies and gentlemen, I'd like you to go to this patch for lerp. This thing in the upper left, and I would like you to insert the following code. Okay? For the fill color for it, we're going to set it by a dynamic variable that's going to be lerp color. Do you remember how lerp color worked?
Fraction.
It's a fraction, and according to that fraction, it interpolates between one color and another color, right? So maybe the color is, black and then white, and depending on if the fraction is higher, it'll be closer to white. If it's lower, it'll be closer to black. It'll be scales of gray. I'd like to suggest the from color will be white, the to color will be red, and the fraction, ladies and gentlemen, will be mature divided by main dot, and it's going to be one of the parameters we put in there, max visible population threshold in main. There we go. Okay. Did people have that? Do you want me to put that up in the big screen? Would that be helpful? There we are.
See this first time. Get naming patches.
Yeah, so just do.
Lerp, color,
So it's very slow.
Autocomplete now.
There's our deal there.
That's what you're looking for.
Yeah, okay, no.
Yeah. So just build.
It's kind of beautiful
Interface, just
when you run it.
what's that?
It's kind of beautiful when you run it.
Yeah. It
Thanks, man.
Yeah.
looks kind of interesting. Okay. It needs a little bit of updating to be sustainable, but I don't think we'll do that.
What's
Oops.
the initial value for the mature
I'm
stock?
going to.
So the initial value is initial immature. It's the one where there's that dotted line from initial immature.
Oh, darn.
And the initial for mature, they die. They die. But that's what I'm saying. To make it sustainable, we need an inflow to immature.
Yeah, right.
So we can actually do that. I mean, that will take just a moment here.
But it's
Oh,
Ooh.
okay.
It all jumped up real high.
Oh, I mumble. Okay.
Oh, so it's so.
Okay. So something's off.
Should be
Let's go test it. Okay, so my hypothesis is maybe all of them are initialized to the same value, but that's not true. Some are higher than others.
It's sort of a double check.
Oh, I did line color.
Okay, some are higher than others. So it's not that they're all initial, well, okay, maybe, let's go try it. Initialize, let's go try this.
Yeah.
703,
Initial value is 0.
no,
But
okay.
I'm telling it it's something else, so null is actually the
So-
initial value. That's kind of.
So you see actually different colors, yeah?
Yep.
Yeah.
But I also realize I'm missing net migration from the output.
Oh, okay. So mature divided by from white to red. Okay, and the max, the question is what is the max visible threshold? I'm pretty sure I provided, okay, what did I tell you to put in there? I didn't put in my own. Was it 500, was it?
20?
20? Okay, and patch mortality threshold was
It's
500?
That's
using
correct.
mature,
Yeah, okay,
but it doesn't have an
Okay.
arrow.
okay. Okay, that's why. Okay, yeah, okay,
All die.
I'll die, okay. Okay, the final thing we'll put in here, and then we'll be done. Ladies and gentlemen, if you go to here, we right now have okay, I have to be very careful here. Okay, here's our mortality rate. This mortality rate is 0.1. We are going to create a flow into Immature, okay? A flow in to Immature. And this is going to be births. And ladies and gentlemen, this birth rate is going to be the product, the number of births is going to be the product of the number of mature ones and a birth rate. Okay? And the birth rate will live in Maine. Birth rate. Birth rate. And it will be 0.1. Sorry. 0. Excuse me. I think it is 0.1. Yeah, 0.1. 0. What's that?
Just the Boolean? Oh, sorry, double?
Double. 0.1. Okay? And then, ladies and gentlemen, births, the formula for births, what do you think it will be?
That variable?
That variable times what?
Big number?
Times mature. So a birth rate times the number of individuals that can give birth, or times the number of sexually mature individuals. Birth rate times mature. Okay?
And then,
Birth rate's 0.1. I think it was 0.1 per year.
Well, 0.1 birth rate, so that's a rate. So it has a rate of 0.1 per year.
Yeah.
Yeah. So the births is the flow for births is birth rate, mean.birth rate times mature. And now we should be able to see. Okay, who would like me to show something?
I have to see what I missed.
yeah, me too.
I know I missed one of the things you were saying, but I'm trouble drawing.
Okay,
I don't have the birth rate put in.
so I put in the birth rate to Maine, and its value is 0.1.
Or just a straight 0.1.
0.1. I mean, probably I should have made it a rate
Rate.
per year. Yeah. And births is then the flow of births, which is in organisms per year, is the birth rate, which is in 1 over a year, times mature, which is the number of organisms. So it yields organisms per year.
So each organism is generating 0.1 organisms per year.
That's right.
Mean is birth rate times mature.
That's right.
Yeah, okay.
That's right.
And the arrow's going from mature to births? Or
Yeah.
births? Okay.
The arrow's going from mature to births. Yeah, that's right. Okay.
That's because the birth rate depends upon the number of mature, not the reverse.
Yeah, exactly. Exactly. Okay. So
It all diffuses to even.
it diffuses to even. Indeed.
So, same error chart.
Yeah.
But that's because there isn't an arrow that's going from mature. So that arrow is going from mature to immature, but it should be going from mature to births.
Yeah. So now we're having migration. Migration kind of smooths out that thing. Now we could,
Mature
if we wanted to,
to births.
add in some extra dynamics. It would be readily done. For example, we could multiply this, times. We could perturb it by a normal distribution. So we could do it something so that essentially we get some stochastics in there. But time is late, and so we'll leave this here. But the final thing we'll do is we could go up to, we can go here up to the rectangle, and we could put in an on-click event.
Migrating.
And when we click on this, we could have this dot mature, plus equals, 1,000. And that will lead to we can actually experiment with this
Here.
in terms of,
What this is saying.
okay, we can run it forward. And then you'll notice there'll be some diffusion around this point, right? You could see it spreading out there.
They're all moving to mine. This should be this dot.
That original disturbance led to a spreading pattern.
Let's see if it makes
On click, sorry, this mature.
Yeah. So what I did is I went to this, and I went down to the on-click handler for the rectangle, and I said on-click, make this dot mature plus equals 1,000.
For some reason it's not going all the way.
I can see the GIS.
It did a little bit, right? If you saw
Yeah,
it change a little
relevance.
bit,
Relevance would be amazing.
I mean,
Yeah,
run
because
it,
this
like-
diffusion coefficient, migration, that would depend on the terrain, right? So it's going to be certain terrain it's going to be hard to migrate into.
Whoa.
Something's wrong with my diffusion coefficient.
Oh, I see. This is a good test. So you did this in patch, right?
I did this in the patch, yeah.
Okay, so here we go on click.
Migration.
So here, I can come take a look
Number of
at,
mature, right?
This is
Tiffany's.
the one.
it's a number of mature plus 1,000.
Plus 1,000.
So
I
what's,
don't know why.
So
What's
now
going
what
on
this
here?
we're doing is we're adding 1,000 on
I'm
click,
not
so we should
getting
see that
migration
spread.
diffusion, so I must
we'll
have
be able to
missed
test.
a step
Oh, no,
somewhere.
we won't be
okay,
able to
can you
test.
run it fast now? Because it's running
Oh,
really
sure.
slow right now.
I didn't
So,
use my own.
yeah, did that, okay. So it is running
Didn't use my own
slowly.
guidance. Auto-
Let's see, that does seem
Like this.
like there's maybe nothing changing. So could we go,
Not
could
spreading.
you drill down to a level of a patch
Let's see,
and
figure out why
go
it's not
see
spreading.
net migration is 0 here right now?
Mhm.
So we want to go check why that's 0.
Right.
So let's go see net migration, and right now it says 0. So you need to call get immigration rate.
Is he,
Yeah, so this
Red
net migration is
immigration,
0.
yeah, that's it.
Okay,
Okay.
Okay?
all right.
Now, so try saving
So
that
for some
and then
reason
try
it's
running
gonna
it.
be not 0. So it's doing that.
Fix that.
I'm just gonna drag this to make it a little
Okay, so I need to speed it up.
Yeah, okay. No, Yeah.
So net migration, get net immigration
Yeah.
rate, that's
All right.
right.
Yeah.
I
So
think I'm
that,
having the same issue
yeah.
with mine.
Okay.
Except when I run the model, this actually doesn't show up.
Okay. So can I check it
Yeah.
out? Okay. So. Oh, sorry.
Yeah, just go back to that corner.
Oh, sorry.
No, I'm sorry.
Okay, neighbor.
Okay. Okay.
Just
So
get out of it. I paid it now back.
here we are. Boom. Okay. And if we go down to a patch, okay, that's the plot thickens. Okay, that's really interesting. Okay, check. Okay.
Migration.
Okay. What
Let's see if that
is
guy's
going
Well,
on?
yeah,
It's
where's
really
the
interesting.
Starting.
Okay. Visible, no.
Of course.
So it's 0.
Okay.
Oh,
So
sorry.
yeah,
Remember
no,
what it was?
yeah.
Like I've done it.
Okay.
in the
No,
past,
I didn't-
so
that's-
it's
Okay, try running this.
practical.
Let me just check on his computer.
It's good.
Okay, so now let's go down to the level of an
Particularly with the
individual.
GIS landscape.
Okay, net migration is still 0. Is it calling get net
I
migration?
think it's calling there, and then, I mean, the only thing I can think of is a mess up in my encoding for the function.
Okay, so let's go check it out. Okay. Hey, come on. Okay, if equals, okay, for neighbor, okay, non equals no.
Migration diffusion.
Oh, neighbor. This is
Okay.
in it.
Yeah, but migration
what?
diffusion coefficient, do you have,
Is
ooh,
that not it? Sorry.
so migration diffusion, is it possible that that's 0?
There you go.
Maybe.
That one hypothesis is maybe that's
This one was
0
that
in your
way.
model. So
Okay.
let's try running that again.
Okay.
So Kurt, what ails it? Migration
There you go.
diffusion coefficient.
Now just click on, yeah.
So where is the migration? Oh, it's level, of course, level of the path.
Yeah, and now hit.
It's
It's
0.
running and it's
Okay,
ready.
so what you need is a migration diffusion coefficient of 0. Migration diffusion coefficient 0.01.
Yep,
Yeah.
it's right there.
Yeah,
I just clicked it because that was our problem too.
yeah. Migration coefficient 0.01. So
Got
can
it.
you put that in?
Yeah, like
Is
population
that?
viability analysis, that type of stuff as well. But what happens if the mortality rate gets higher, if the conservation
All right.
Yeah.
is split? Is that,
Hmm?
this has got enormous application.
Yes. Yes. Hence the reason why I decided to
Okay.
dedicate a PhD towards it.
So this is,
Yeah.
let's go up to
Good job.
this.
Good choice. You do a lot of
Okay,
this.
there you go.
I
There you
use
go.
patch models, even not that complicated.
Yeah.
But each model can have an enormous.
So it's
application.
diffusing,
For particular
Okay.
models.
it's diffusing out. Can you see it?
Yep.
Yeah.
Obvious.
And it,
Yeah, but prove this is like the baseline. Obviously, it's very.
So if left untouched,
Yeah,
it kind of
yeah,
all just
um,
diffuses together.
It's
So we're-
right now it
I mean,
diffuses
you can-
together. I have a
you can
version
build
of it where
anyway,
it
so it's-
kind of
that's the
exhibits,
problem. It's just the space is so big that you can publish by any new model. It's almost like a new paper to publish. But right now I'm building one that's trying to look at people's addiction habits related to tobacco use and how does their usage change?
Yeah,
with
so
different taxation
you can get-
strategies used.
Yeah.
So it's
Looks fun.
yeah, yeah.
Don't show it to somebody who's.
Yeah.
Play with me.
it's turning yellow for some
Double
reason,
left
and I'm
it.
not sure. Is it your
I
alert?
think that's just you, actually.
No, this is done as a slight variant of this, and
Before alert color existed.
I think that may be
Yeah.
may be the case actually.
Yeah. When I first started, actually, this was on Initialize 6, and I don't even go back that far. Nate was Initialize, I don't know, 3 or 4 or something, but on Initialize 6, you know how you can draw the arrows or the lines behind the agents? When you connect an agent, you just click draw a line behind agent or
Oh,
something.
yeah.
Well, we had to do it by drawing a line, right? Like, so you had your person shape, and then you would drag a line onto that person shape, and you would replicate that line for each neighboring agent. And the beginning and end point of that line would be, this dot get x minus that dot get x, and that would be the x difference. And so you'd have to get in there, and I mean, it's not that complicated. It's just Euclidean geometry, but it's easier to go click, works, you know. So lerp color didn't exist when we first started. You had to do this other kind of crazy, more difficult equation or function. But as you begin to use it, they go, oh, you like that? Okay, we'll just put it in automatically.
What was the previous function like? For this color, this color, this.
Yeah,
Basically.
yeah, I don't remember exactly. I kind of avoided it because it was a little hard. So
Okay.
Anyway.
So,
you choose the red, green value, like the RGB value and stuff.
So, ladies and gentlemen, what we saw here was a model that basically can be easily mapped into GIS context, but it allowed us to associate agents with patches. And by virtue of associating them with patches, we could have actually fairly complex dynamics. Here we happen to select system dynamics for describing the particulars of the variability, the dynamics that we saw here, but we could additionally add, of course, state charts if we wanted to. For that matter, we could have some discrete event modeling on a per patch basis. However, I think that showing these system dynamics, starts and flows here was of particular relevance because often in ecology, for example, we might have some compartmental model that characterizes some ecological dynamics for a small region. And perhaps it's fairly applicable for a small region, but once you start getting into big spatial areas, it doesn't make sense to deal with it in that sort of an aggregated fashion. And what we can do with very straightforward procedure is basically capture those dynamics in each patch for, say, half kilometer by half kilometer region or something like that, and then have interactions through migration through neighboring regions. Right now, this is all very uniform, but we could have randomized this migration diffusion coefficient within the model so that rather than being a uniform quantity, we would actually have some terrain which had different characteristics. So rather than being, this, we could have uniform between 0.005 and 0.015 or something like that. And that would lead to different types of diffusion. In other words, this would lead to certain squares being hard to diffuse into, certain squares being harder to diffuse into, etc., which would lead to some greater levels of heterogeneity. It wouldn't all blend quite as uniformly, or at least it would take a longer time for it to blend. We could also add noise processes, etc. The point is we can capture endogenous dynamics within a patch, and we can richly characterize that dynamics but still have interactions across patches. And we could map these things to very clear latitude, longitude positions, which could associate them with very definitive and empirically grounded attributes. So, very straightforward type of model, can be used itself in a multi-method context within each patch, but very powerful with system dynamics for these patches, and quite amenable to to creating larger numbers of patches or smaller geographic areas associated with each patch. There is a limit to scalability, and we'll talk about this tomorrow with some issues with performance of these models. It turns out that you've got to be careful, particularly when you're dealing with system dynamics models, of scaling to too many agents. But with a bit of cleverness and savviness, there's a fair bit you can do to sort of keep it performant within certain ranges of scalability. We'll try to talk about that tomorrow in the context of performance limitations in models. But I think that's all for today. Thank you very much for your attention, your stick-to-itiveness, and your dedication. And tomorrow morning we'll be reconvening for a set of additional topics, including some discussion of sensitivity analysis, calibration, some discussion of performance issues, a little bit at least on best practices, and couple other topics we haven't had a chance to look at. And as time allows, perhaps a case study or two. Okay?
And we'll be next door again for the morning?
Oh, that's upstairs where we were?
Yeah.
Okay, great.